So our next speaker is Torben Petersen. He's a distinguished technologist at HP and a lead HPC storage architect for EMEA and APAC. He's worked with Lustre in one form or another since 2007 in companies such as Sun Microsystems, Oracle, Xerox, Seagate, and Cray before joining HP. Torben works for the HPC storage business unit and is involved in everything from solution design, customer acceptance, to defining next-gen HPC storage for HP.
Thank you. So by that you got, I'm actually not a developer, so everything you heard so far is from developers who actually knows Lustre. I just use Lustre, which is kind of a different thing. Secondly, I was asked to do something slightly different. So this talk doesn't actually speak directly to Lustre and Lustre functionality, but how Lustre fits into a larger ecosystem. And it is, unfortunately, I would say, partly the view of HP, which means that it's really hard not to speak about products, but I will do my best not to talk about anything that comes out of our portfolio. But this is more about the way we see the future of Lustre fitting into our customer sites, our customers' requirements, and so on and so forth. Specifically around the way, how do you manage data for a lifetime? And part of that is because that should have been a build-up slide. So is this in PowerPoint? Well, it's obviously something doesn't work. Okay, I can do that anyway, but it's supposed to be a build-up slide because you kind of want to show you what our typical customers look like today. And those customers are not necessarily the customers like Oak Ridge with a 700 petabyte single namespace and those kind of things, because those guys actually know what they're doing. We don't actually need to help them. Actually, they need to help us, and sometimes because they see problem at scale that nobody's seen before. But we also have a lot of customers in the commercial space or in the less typical space. I mean, we even have a customer that has a Lustre file system that's called Zalando. Now, you wouldn't say that as an HPC type customer, but they still have a file system. We need to fit into that environment. So the idea here is we are living in a heterogeneous society today with regards to compute. We have our compute nodes today, which we always had. They're now very complex compute node with a lot of GPUs and a lot of other accelerators, different architectures from a CPU point of view, and so on and so forth. There is point. Good. And one of the things we've been trying to do is accelerate certain things by adding storage to the compute nodes. That storage could be in the form of 3D XPoint. And yes, I know Intel has just canceled future development of 3D XPoint, but it's going to be around for another 3 to 4 years. And it will most likely be replaced by something similar that can give us those accelerations. Now, the problem with node local storage is that it doesn't actually allow you to share that storage, which is why Deos, for instance, have come into the picture. So Deos allows us to build a file system covering multiple nodes and being parallel access to that file system. We can also add local NVMEs to a lot of nodes, which is also done frequently, but those nodes are unfortunately very node specific. There are things we can do that, and I'll get to that in a second, to enable that as well. But that's how the compute side looks. Then we have our parallel file systems, whether that be in Lustre, whether that be in Spectrum Scale, which still has a lot of legs in it, despite the fact that it's a commercial product from IBM. And we are now seeing more and more NVMe or fabrics coming out. All of these things need to act together in a way where we can actually use that data in an intelligent and balanced fashion. But the problem with the file system today is we see more and more what I call tiered file systems or hybrid file systems, depending on how you want to slice and dice the OSTs from the OSSs. And that means we have a flash tier and a disk tier. In some cases, we have multiple flash tiers because they're formatted differently. They could be RAID 10 and parallelly clustered RAID in the same file system. You could have disk tiers that are used for capacity. You can have disk tiers for performance. So you can have very complex file systems. And one of the last things you want to do is consistently and continuously move data between the tiers in an unstructured fashion. It has to be intelligent. That's what we call data services. And that's both about data placement, but also about data movement or migration. And that's a really important component. And then on the right-hand side, we have our archiving system because, strangely enough, people want to save their data for a long time. Some of our customers save their data for 30, 40 years, which unfortunately means media migrations over and over and over again, which is another hard part to do. And all of this is tied together nowadays with really, really fast networks, usually based on HDR, 200 gigabit Ethernet, with Rockies becoming a good second to that. And obviously we have our own Slingshot, which again is an Ethernet type fabric, but different management. Now, when you have all of these things together, you need to be able to not only allocate data to the right place at the right time, you also need to be able to move it from a lower tier to a higher tier in anticipation of a job. And that job needs to have that data available at the right tier when that job runs. And if that wasn't enough, you also need a third thing, which, so this is actually not my last presentation. This is not a good thing. So the one I sent on Thursday is not this one. Okay, doesn't matter. I may be missing some slides. I realize that there's supposed to be something on top here as well. Honestly, I need my presentation. This one has so many slides that I've redone. This was
the PTX, the PowerPoint one?
I sent over on Thursday. The last one was called Final. This is not the final one.
Final one?
No, there's only oh.
Perhaps it will be better, this one.
Actually,
It's okay for you?
yeah.
Okay.
That's the one with animation. So let's speed through this animation until we get to the end. Because one of the things I wanted to mention here is the fact that I forgot about that part. We can now actually use that using persistent client cache, or LROC is called in the spectrum scale world, which is obviously a new way of handling data as well. But that's not really an important thing. The important thing is this. We're getting to a situation where our file systems are growing to huge sizes. Very few customers has just one file system in there. They have a mixture of different file systems and different tiers. And we need to be able to not only manage this as one big entity, we also need to be able to have tools that can manage the data in there. That means we are creating what I call a single virtual namespace that covers all of the different aspects in there. Because as a user, you need to be able to ask your file system, where is my file, and not get one file back. But you could get a list of files, and you have a file that's located on Deos. You have a copy of that file that's located on Flash here. You have a version of that file or two that's actually located on HDD. And you've got 4 backup copies on your tape. Because that's how you manage your file, your data. And that needs to be automated, right? The next slide is really only about why we need this. And again, as I say, some of our users are using humongous data sets that needs to be reused over and over again. It's not just scratch data anymore. And that's really important to remember. It is dynamic data being reused and reused for reference purposes. And that could be anything from our customers at Airbus, where whenever they need to service a plane out on the field, when they have a problem that affects a plane standing at a gate, the service engineers in Toulouse needs to be able to access every piece of support data for that exact plane. Not the type of plane, for that exact plane, which is located on tape today. That means it could take up to 30 minutes to get that data ready. And at that time, the plane is just sitting at the gate. Passengers in the plane, if we're unlucky, and it costs a fortune for every second of delay you have. If you can speed that up by an order of 10, that is money in the bank directly. And we all have similar type of situations out there where this is needed. So data management and data mobility is really importance. Now, so my first bit here is about intra-file system data mobility. How do you manage data inside a single namespace when you have a flash tier and a disk tier? And again, we are using a lot of the features in Lustre. Now I'm specifically focused on Lustre. So, the progressive file layout is one of the biggest advantages I've seen in modern time, or in the lifetime of Lustre, I would say, which I think is one of the most useful things we've had in a long time. File level replication is still a bit immature, but we are using it. But very few customers are. And why is that? Because it's hard. It's not that easy to do it systematically. If we have a tool that can do that for you, it will speed things up. It will enable users to focus on what's really important, i.e. using the data, not managing the data. And some other things. But Lustre lacks a lot of these components today. Yes, you can do a manual data migration using LFS migrate and so on and so forth, but it's not really a very efficient way of moving data around. So what we come up with is a solution we call data services. Again, we're trying to use open source tools, but we're also trying to use some modern technology. So this is actually based around a Kubernetes environment with three nodes in a cluster in order to manage these things consistently over time. But what's important in here is the services. So if you look at the right side here, or left side here, we have our basic file system with a flash pool and a disk pool. Obviously, there is data on metadata or data on MDT as well on the metadata servers, but that data is so small that we shouldn't really focus too much about it. And it's usually static. It doesn't move very often. And then on the right, we have our cluster. Now, Lustre doesn't know that that cluster is there, but the cluster knows about Lustre big time. And inside that cluster, it does a number of things. First of all, it does indexing of the cluster. It creates a mirror copy of the metadata. But it doesn't do that in a database because databases are slow inherently. And we need to be able to do hundreds of searches on that data in a complex way per minute, easily. And that needs to be done without affecting the performance of the Lustre file system because we still need that to run at full tilt. Once I have that mirror in index files, and by the way, those index files are stored on the Lustre file system, so we have parallel access to it. And it's also obviously on the flash tier, so we can access it really quickly. And it can be handled by accessed by multiple nodes at the same time. Again, parallel access to those flat files. That means I can read those files really quickly, I can update them really quickly, and I can utilize them both in a static state or in a dynamic state as my jobs pertains to it. Then we have a policy engine, or a search engine rather, that uses a number of queries to that, and uses SQL language to do so, because that's the easiest way for me to write very detailed queries on the data. But it's not an SQL database. That's really important to remember. After that, we have a policy management system, which essentially is based around the Kafka engines. We can do out-of-order searches and some other things with NQ and so on and so forth. It's really just using the best tool for the purpose at any given time. And then we have a tiering engine. Now, the tiering engine creates a just-in-time list of files to be moved and distributed to one or more data movers. And that's something we externalize. So the data movers here are actually dedicated nodes or embedded functions in the 3 core nodes that can move these data in parallel. And that means I can get really high data movements based on those policies. Now, those policies could be anything. I need to speed up a bit. The important thing is that whole hierarchy here can be accessed by a number of different users. So the end user can actually do a search on the file system using their own files. They will only see their own files that they have right to see, but they can use the same tool instead of using a find in Lustre, because this is 10 times faster than anything Lustre can do. It can be accessed, obviously, by system administrators, because they need to modify the policies, and the policies by themselves is also stored on the Lustre file system, so it's all encapsulated in one site. But we can also access this using a resource manager like Slurm or PBS Pro. That means that those jobs that we submit to PBS Pro or to Slurm can actually have a prologue script that says, before I launch this script or this job onto my compute, I need to make certain that this list of data is put in at the right place, for instance, in Flash. So it will actually find the data, no matter where it is in the file system, put it into a dedicated directory on the Flash tier. Once it's done, it can tell the resource engine, these data are now ready to go, you can launch the job. The job is then launched, it has access to that data in a dedicated spot on the file system, most notably in the Flash tier. And then once it's done, it has a postscript that will migrate data to wherever it needs to be. And that can run in the background with no user interaction or no admin interaction forever. So the policies are really important. I mentioned the file search, I'll skip that for now. This is a standard policy. And some of you may think it's familiar because we're actually using Robinhood syntax. We're not using Robinhood because honestly, Robinhood is too slow. It can't keep up. And I know some of you are developing that and like Robinhood a lot, and I do like Robinhood as well, but it's not fast enough to manage a file system like, for instance, the Orion file system at Oak Ridge, 700 petabyte, 60 billion files once they're done. That's no way a standard policy engine, read and changelog could keep up with that. So we use the same type of policies because it's easy to write and so on and so forth. So this is standard policy, just doing what we call Flash maintenance. Any Flash on the system that is more than 75% full get exposed to this. You can set the threshold yourself, obviously, and then it moves data off. Again, it uses the oldest and the largest files to move off unless they are sacrosanct, which means that they have a no migrate flag on them. And that's kind of one of the things we do with these systems. But it's not the only use case because we're still working with customers to figure out what the use cases are. We also have the use case of some other customers that just want to use this function, not for moving data, but for getting rid of data. Find old temp data that hasn't been used in 8 hours, get rid of it. Now, you can do that with any other script as well, but having a policy or multiple policies that can actually also identify location in the file system, not just the file name or the file type, but anything you can specify in metadata can be part of these things. That makes it a lot more flexible in our minds. This is actually what the whole system looks like. I won't go into any details, but I put it in there so you have the slides and can kind of see what our thinking are. And the idea here is just that these things are adaptable. They are manageable. They have something we can replace. There's really no proprietary components in here outside some of the code that we do on top of this. The rest is just, anyone could do it if they wanted to. I don't recommend it because it's been a pain in the neck actually getting it working. So you kind of get the picture. Now, the next thing I want to talk about is inter-file system migration, because that's just as important. And we have a solution called DMF. It's been around for a long time. DMF is something that would not only allow you to manage a Lustre file system. Originally, it was an HSM solution, but now we migrated to also be a backup solution using version backups. And we can also do horizontal data movement. That means I can also actually take any of these file systems I have up here, whether it's Spectrum Scale, Lustre, external NAS, we can do DAOS, we can even do S3 front-end nowadays. I can actually use a policy to move data from Spectrum Scale to Lustre, or from Spectrum Scale to S3, or from S3 to Lustre, whatever I want to do. Again, using policies. And again, it adds flexibility to that complex system I described on day one. Inside that, there is a lot of services running. And again, it creates a data center-wide view of all the file systems you have, all the files you have in those file systems, and gives you access to location and moving them to where you need them to do, or erase every single file from a user who is no longer part of the project, for instance, whether or not the data is on flash or on tape. In the back end, we can use almost any long-term storage component. We can even read PFS systems, keep mixing it up. PFS is unfortunately a product. The other one is the IBM. Yes, PSS, sorry. There's too many acronyms in this world. I'm getting confused over time here, right? So yeah, HPSS, it can actually read them, it can't write them because we use our own open source tool for doing that, which is called OpenVault. But we also have things like 0-watt storage. And that's exactly what it sounds like. It's big, stupid enclosures where we can actually spin down the drives. We use a ratio code in between the different nodes to be able to safeguard data in case a disk doesn't come up. But essentially see that as virtual tape. But we can read data much, much faster than we can from an existing tape. We still use tape. Now, people know me says, I've been claiming tape is dead for the last 15 years. I've been wrong the last 15 years, and I'll probably be wrong for the next 15 years too, because tape seems to be around to stay for a long time, because it's still cheap. It's not easy, but it is cheap. And then we have cloud-based solutions. I thought it was really strange when I had the first requirement to say that, oh, we need an archiving solution, but it should be based on Ceph. And I thought, why use Ceph for something like that? But it makes a lot of sense because you can have equal access to all of that archive by other means that Lustre doesn't provide. And so on and so forth. So that's a lot of options. Now we have one tool that can actually handle all of these at the same time, which is important because we can have different tools for everything. Now what does actually DMF look like? And I have one slide that explains it clearly. And it looks, yeah, I know what it looks like. That is actually the old version. The new version is much cleaner. We eliminated 3 or 4 boxes or something like that. But the important thing is that, again, we're using standard type of tools. We're using a shorter database, Cassandra, because, again, we need to be able to scale to sizes that handles multiple hundreds of petabytes or exabytes eventually. We need to be able to do intelligent searches on these data using Spark, for instance. We use out-of-order engines like Kafka and so on and so forth. So that's nothing really unusual here again, because that's how we try to do things at HPE. So as much open source as possible, but package it in a way that makes it easy for people to use. And again, we have a big plan of moving this into what's now called the data mobility concept, because data migration or data management is no longer everything it needs to be. It needs to be mobility. That also means that adding multi-site replication, adding tools to be able to share data in a global fashion, again, dynamically, automatically, policy-based, is really important to us as well. And that also means we need to be able to access every single piece of client data out there, whether that is your standard change logs from Lustre, whether that is your index from Spectrum Scale, whether that's a NAS file system, we actually have to scan the file system actively to get the data. But that is really the key point of what we're trying to do. Create an environment where it's easy by using policies to set up a data migration, data management, data archiving, data locality, and so on and so forth, in order to get the data at the right place at the right time. And that also means combining it with the data services you saw earlier. So the evolution of this is actually getting to a point where we have one seamless activity that stretches from DAOs at the compute to dead tape premises in the other end, and it being one virtual namespace. So that kind of gets us to this point about what we're trying to do here. And basically, one size doesn't fit all. That's why we try to do everything modular, everything dynamically, and not having to go all out on any of these solutions. So the smallest systems for either of these two solutions is 3 nodes, again for resiliency purposes. And they can scale to hundreds of nodes each. We haven't actually gotten to that point with any customers, but we have customers with about 25 nodes in a single cluster for one of these purposes, because it's needed for all of these different work steps and for delivering performance. Because moving data is not just about moving one file from one point to another. It's about moving petabytes of data on an hourly basis in some cases, or at least a daily basis, from one tier to another. Whether that is just for archiving purposes, whether that is for restore and backup, restore and restart, checkpoint and restart, or something else. It doesn't really matter, because we don't dictate what the customers do with these systems, but we have to make sure that we can actually deliver the functionality they need in a supported manner. It also means that we can't write the policies for you. We need you to write the policies, and I'm happy to take part of them because that gives me new ideas what to do next. But I don't know every single workflow in the world. Actually, I probably know a fraction of the ones out there. And I keep getting surprised about some of the user workflows, especially now that we have then AI use cases and so on and so forth. That really makes things really difficult. And that's why we need that to be easy to manage by users. Databases or not databases? That's always a question. A database is nice, it's easy, but it has problems. And one of the last things I want to do is having to go to a customer and says, well, we can give you all of these functionalities and you can be in a nice, easily managed database. Unfortunately, you need to buy a mainframe to run that database because otherwise it would be too slow. Now, actually, we do sell those kind of mainframes at HP, but no, let's not go down that road. And finally, what do we do in the future? Now, we're trying to pioneer some new open source tools out there, like the common metadata framework. Again, it's not just for Lustre, but it's for an end-to-end management of those metadata, being extended metadata and so on and so forth. Because one of the biggest challenges we have with metadata is that I can find for a file, I can find a size, I can find a user or something like that. But what happens if I'm trying to find files created by users who are no longer with us for different reasons? They may have left the company, they may have passed away. How do I find their data without knowing how they name things? So we need more data to be able to look inside the files. Now, it's going to be really interesting if you go back to Sebastian's earlier presentation about not being able to access some of those data if you use client-side encryption, but that's not my problem. That's his. We're also looking at using some of the FAIR principles going forward. Again, how do I access data? How do I make it available? How do I make it reusable and so on and so forth? That's really important over time. And then finally, AI, machine learning and so on and so forth is probably key to make this work at large scale. I have no idea how we're going to get there yet, but it is something we're spending a lot of time on. So I know this was a lot of non-Lustre talk, but I wanted to kind of give you an idea about how we see the big picture and where Lustre fits into this component or this environment. And it is an important component because that's where the big performance is. None of the other file systems, maybe with the exception of Deos, that still has some teething problem, can deliver data as fast as Lustre. And it's still been the driving point of a lot of things we do. Performance, performance, and more performance. Thank you very much.
Thank you, Torben. Any questions?
This close to lunch? I doubt it.
You wrong?
Hi. So I don't like to write policies. So does your product come with sort of GUI where you can drop boxes and stuff?
Not yet, but it is being discussed, yes.
Yeah, and the reason I'm asking is I've sort of, my experience is that the workflows it is something related to users, and a lot of users are not particularly good at writing special stuff, and they would like to have boxes and put stuff inside the boxes.
Right. So one of those aspects I haven't been talking about, mainly because that's still kind of NDA in the company, is how do you automate policy creation? How do you create a policy based on monitoring a specific workflow? Is that workflow is common? How can you actually snapshot that and put it into policy? Those are kind of things we're looking at. I have no idea how we're going to quite do that yet. That's one of the areas where machine learning may come in useful. But we are looking at how can those policies be set automatically by the system itself because it detects a common workflow. But again, it's early days for that yet. But we are trying to figure out a way, how can we help you write a policy that doesn't require you to actually learn the sometimes quirky syntax of Robinhood and so on and so forth.
Any other question?
Uh-oh.
You mentioned that there would be zero user interaction when setting up data before a job starts or something like that, but wouldn't the user at least need to specify, like, I want to access the files in this directory or something like that?
Yes, or you could use something like a product index, or you could use some other policies to actually define what those files are. It's not 100% foolproof, but it could be done as well. So we are looking at ways of how can we define data that should be reused, or how can we find a sample of data that should be part of that Prolog script to be pulled back. And again, it comes into the workflows and so on and so forth. In some cases, yes, you need to dictate things, but if you're a user and you launch a job into Slurm, for instance, you still need to define your files, right? Because if you want to run a simulation on a set of source files, you have to identify those source files and put it into the Slurm script submission any which way. So,
yeah, I've seen examples also where the file paths are hard-coded in some application, but
right.
So yeah, users are lazy, and the less interaction they need to do with the systems, the better. A second question also, do you have already working integrations with Slurm where your framework can say, this job requested to move data, and now it's ready, so that Slurm knows to wait?
Yes, so we actually have that in the latest release of our product. So, and it's been something we've worked on for the last year and a half. And again, we're using standard message patterns for that as well. So it's not really rocket science. It's just how do you define when it's ready. But yeah.
Is that something which will be upstream to Slurm as well?
That's a very good question. I expect so. I mean, most of these components are open source, and we're trying to open source our project, which unfortunately, when you work at HP, takes forever. But yes, that is something we're looking at.
I guess Slurm is GPL, so somebody will have the source code.
Probably, well, for the GPL stuff, yeah. But in our case, it's more a question about how do you do the scripts, which is not really Slurm. So
Yeah. Okay. Thanks.